It's forecast to be one of the most serious storms to hit New Zealand this century, and authorities are warning residents not to be complacent.
Well, if Auckland's empty streets are anything to go by, we are taking this very seriously. Gabrielle has already broken records and is set to break even more. It's on a scale we're just not really used to.
Cyclone Gabrielle is already wreaking havoc as hurricane-force winds forced flight cancellations and power outages across the North Island.
My main message to people across the country is to take the severe weather warnings seriously.
Red warnings are now in place for severe downpours across the Coromandel Peninsula, Gisborne, north of Tolaga Bay, Auckland and Northland.
Right, Portuguese and Gisborne are the latest districts to declare a state of emergency.
Homes in Northland and Auckland are already without power. Authorities are warning residents to expect prolonged outages.
We're hearing new words and phrases like stingjet, inverse barometer and vorticity. And it's turned us into armchair meteorologists. I'm Sharon Brett-Kelly, and today on The Detail, what makes Gabrielle so freakish and what does it tell us about our summers in the future? Well, I'm heading out of this dreadful weather and inside to talk to Ben Knoll, who's a meteorologist at NIWA. Well, what a time for a meteorologist.
It is the time. You know, these are the types of events that really gets the adrenaline going, and this is kind of why we're here. This is the nature of our job. So a lot of meteorologists, it's often storms and hurricanes or events like this that kind of get you into the field in the first place. So yeah.
So let's kick into it, Ben, because how would you describe Gabrielle?
Yeah, Tropical Cyclone Gabrielle, it's been quite a ride. It started off late last week as a tropical cyclone in the Coral Sea and intensified quickly to a Category 3, their fuel being these really warm oceans. And as it moved down toward New Zealand, there was a track late last week that was predicted to come quite close to the North Island, and it looked pretty concerning, 5 to 7 days out for it possibly tracking close to New Zealand. And what we've seen is that come to fruition and expected to see low pressure levels that we haven't seen in a very long time or ever in some places, and akin to the likes of Tropical Cyclone Giselle, the Wahine storm in the 1960s.
The inter-island steamer Wahine lies on its side today at the mouth of Wellington Harbour. A preliminary inquiry into the disaster began in Wellington today. Statements have been taken from survivors and from crew members.
So it is shaping up to be quite a memorable event, and has, from a meteorological perspective, has a lot of interesting facets to it.
One story called it freakish features. So can we go through some of those characteristics that set it apart from other big events? What stands out for you? What are those special things about Gabrielle?
Yeah, Gabrielle, as it's moving down toward New Zealand, is expected to slow down and actually very briefly track toward the southwest, tucking it really close in tight to New Zealand, toward the northern part of the North Island. And that little jog southwest and track is actually what's going to amplify the impacts across the North Island. And as these tropical cyclones move into the mid-latitudes where we live here in Aotearoa, New Zealand, they begin to interact with other weather features on the map. Sometimes they're features that are in the Tasman Sea. Sometimes there are other big high-pressure systems in the Southern Ocean. And the interplay between the tropical cyclone and those other features for each event is very unique. And in the case of Gabrielle, what we actually have is a feature that's coming in from the Tasman Sea that's kind of almost like fingers reaching out and grabbing the center of circulation from the cyclone and bringing it back just a little bit closer than it otherwise would be. And we've also got this big area of high pressure to the southeast of the country, and that's acting like an atmospheric stop sign. And preventing Gabrielle from quickly moving away. And it's these small factors that will make this event, unlike your average weather system, unlike your average storm for New Zealand, months worth of rain, damaging wind gusts, coastal inundation.
A little bit of elbow grease, fill some bags and help help protect the property a wee bit.
A property he's owned since 2009, and now it's in the firing line at Buffalo Beach.
And we're just preparing to move stuff away from the front of the house where we believe it's going to really get thumped.
And it's, these small intricacies in the atmosphere that can have such big impacts on our lives.
I've been looking at one video because there's a whole plethora of videos and satellite pictures and all that kind of thing. And this one was talking about it going from a tropical cyclone to a cyclone.
Low pressure, tropical cyclone, non-tropical cyclone, whatever.
As it's moved down to New Zealand, because New Zealand is subtropical, is that right, geographically?
Yeah, so as the system moves out of the tropics, it moves away from its energy source. The energy source is oceans that are above 26.5 degrees Celsius. And of course, our ocean waters are not quite that warm. So as that tropical cyclone begins to move southward into those cooler waters, its characteristics begin to change. And it begins to interact with other things, the jet stream, other weather features that exist in the mid-latitudes. And what we often see during that time is a process called extratropical transition. Now, it's a pretty long and technical term, but basically it describes the period of time during which a feature, a tropical cyclone, is changing from being purely tropical to being extratropical or moving out of the tropics to a normal, what we call mid-latitude cyclone. So in many ways, what we're dealing with is a hybrid, a system that still has some tropical characteristics, but also is now assimilating itself into the mid-latitudes. So it loses the tropical off the front of its name, but it doesn't mean that it's any less impactful here in Aotearoa, New Zealand.
And so it's being fueled by cold air, not hot air, and it's changing in shape.
Yeah, that's right. Now, one of the things that we see during this process called extratropical transition is the wind field. Typically during a tropical cyclone is very tight to its core. These tropical cyclones are well aligned in the vertical, and that keeps all of those really intense winds kind of right around the center. But as it moves outwards toward the mid-latitudes into those cooler seas, and begins to interact with things like the jet stream, the wind field does begin to expand, and it can encompass a larger geographical region and actually provide a bigger impact across a wider area. And that is actually what puts northern New Zealand in a bit of an unfortunate position. You think it's moving out of the tropics, it's changing characteristics. These all sound like maybe good things, but unfortunately the way the atmosphere works is going to actually lead to a deepening and an intensification as opposed to the opposite with this system here.
There are some phrases that have popped up over the last few days. One is the inverse barometer effect. Can you explain that to me?
Yeah, the inverted barometer effect. This is something that we see with very deep low pressure systems. And low pressure systems, the winds around this low pressure system swirls inward toward the center. And where those winds meet, they rise up. Okay, so that causes the air to rise and also can cause the sea, which kind of sits below it, also to rise. So what you're seeing is a rising of the sea level with a very deep low pressure system because of the ascent, the upward motion that is associated with these really deep lows. So you have the sea level, because of that effect, sitting a little bit higher. And on top of that higher sea level, you have really strong winds, of course, with these cyclones.
New Zealand's northernmost point recorded the strongest gusts of 140 kilometres per hour on Sunday afternoon.
That's the fuel for big waves and rough seas. So
with every wave that just smashes into this footpath, more and more concrete and debris is washing away.
The combination of the inverse barometer effect, then compounded with these big waves, causes the risk for coastal flooding, coastal inundation along areas that are exposed to these really strong winds.
The far north the first to feel Gabrielle's fury, whipping up huge waves at the usually placid Karikari Peninsula.
Now, fortunately, with Gabrielle, there is a tiny bit of silver lining, and that is that we actually have neap tides, the lowest tides of the month that are coinciding with this storm. If we happen to have spring tides, the highest tides of the month occurring during Gabrielle, the situation actually would be much worse. So there is a small silver lining. We are, of course, expecting, we already have seen water overtopping. We're expecting more coastal flooding during that early morning Tuesday period with these effects of the inverted barometer and the big waves compounding to raise the risk for coastal inundation and flooding.
You tweeted that the cyclone's interaction with Tasman Sea vorticity will cause it to deepen and slow, and I think you have just been speaking about that. But again, another word that I've never heard of, vorticity.
Yeah, vorticity. One that meteorologists are pretty familiar with, but probably not the average person. But basically, what we look for in the atmosphere are areas of spin. Because when you have spin, you can have stormy, unsettled weather. So we want to understand, where are these areas of spin? Where are they traveling? You can also classify them in terms of intensity. Is there a lot of spin? Is there less spin? And what we do is we can look at the spin that is associated with the tropical cyclone, that entity, and then we can also look at other areas of spin that are occurring, let's say, in the Tasman Sea or in the Southern Ocean, and how they may interact with the cyclone spin. So when I look at my maps, what I see is some areas of spin or rotation in the Tasman Sea that become integrated with the cyclone. And as they kind of wrap into the cyclone, I mentioned it before, it's kind of like fingers reaching out, and you're grabbing the ball that's coming towards you, the ball in this case being the cyclone. So that little vorticity that, otherwise probably if it was in its own, on its own, it wouldn't mean much in terms of our weather. But in this case, it taps into the cyclone at just the right time to reach out and pull it toward the northern North Island. And these small-scale things, we've seen it as I track systems in the Northern Hemisphere as well, with Fiona, which affected Nova Scotia in a really rough way during the hurricane season late in 2022.
A hurricane, a tropical storm, and 3 other systems spell trouble in the Atlantic. Let's go right to meteorologist Tom Sater in the CNN Weather Center. So, Tom, let's start with Hurricane Fiona. It could be one of the most powerful storms ever to hit Canada, right?
Oh, most likely. In fact, the lowest pressure they've ever had in Canada, we measure in millibars, is 940. This is going to be about 925, 935. That's equivalent to a Category 4.
These, seemingly innocuous features in the mid-latitudes can end up playing a really important role for intensifying or amplifying the impact when it does come to it, say a tropical cyclone, tracking into a region. So it tells you that, it takes almost a perfect storm of factors to cause something as impactful as Gabrielle. It's not just any one thing.
A sting jet, what's that? And is that still a worry here?
Yeah, so what we're looking at here is a very intense area of wind in the lower part of the atmosphere that can form on these systems that are moving out of the tropics into the extratropics around the edges. It's often kind of what we hear maybe in the media, the sting in the tail. As the system moves away, we see these really strong winds that wrap around on the backside. And that is, in fact, one of our concerns. The cyclone itself, probably moving toward East Cape, but this area of intensifying winds on the southern and western flank of the storm, flowing from around the Wairarapa and Wellington toward Taranaki, and then back into Auckland and Northland, kind of a second round of intense weather, indeed could be associated with this, what we call a low-level jet, an area in the lower atmosphere that is a very intense wind that sometimes finds its way down to the surface. So this is kind of the sting in the tail of Cyclone Gabrielle, and one of the reasons why the impact is going to be prolonged over a few days rather than just a short and sharp event.
Can you just describe what your workplace is like? I mean, I'm thinking, are you surrounded by screens and, satellite images, and what's it like there?
Yeah, so, at NIWA, we have an amazing array of tools at our disposal. We have 3 supercomputers, and on my workstation, I have a one screen, but it's basically the size of 3. It's very long. And I have a terminal at which I'm basically tapped into the supercomputer at all times. We have modeling, very high resolution modeling, about as high as 333 meters, constantly running, churning out new data sets that help the meteorologists at NEWA, of which there are many. There are some that do purely research work. There's others that do operational tasks to help inform our clients, like Fire and Emergency, the Department of Conservation, Ministry for Primary Industries, of these hazards. And it's my job to, I guess, tell Mother Nature's story, right? So I'm taking all that data and distilling it in a way that is easily understandable for those that need to make important decisions. That's just one aspect of my job. There's a short-term component. We do long-range forecasting as well. Timescales out several months and years in advance. And of course, when you're talking about longer timescales, you can't get quite as detailed. You're talking about general themes. Will it be wetter, drier, warmer, cooler? Those types of things. La Nina, El Nino prediction. So it gets pretty intense and in depth. But we have a lot of amazing people at NEWA, really dedicated people to really providing cutting edge science to New Zealanders, and I'm honestly thrilled to be a part of that. I think we live in a really unique place here, being from the United States. New Zealand, 4 seasons, 1 day. And there's no doubt about it. A small island in the bottom of the world, and we've got to really look out for each other here. And I do really like playing that role and helping where I can.
And so with this cyclone, is it telling you anything about how things are changing here for us in terms of our climate? Does it mean that you have to sort of rewrite your forecasts?
Yeah, it's a really good question. And, in recent years, we have seen things like marine heat wave, for example, probably a phrase that a lot of listeners might be familiar with.
A marine heat wave that's keeping the ocean much warmer than usual is expected to stick around for the rest of summer. But while beachgoers are happy, there are concerns about what it means for marine life.
But as of maybe prior to 2017, wasn't really a phrase that would have been uttered in the public domain, but has since been injected into the scientific lexicon, or the average speak, really, because of how it's becoming more and more frequent. And these types of things have to be considered into our weather forecast. How are they impacting weather systems that are moving over top of them? How might they be playing a role in Tropical Cyclone Gabrielle? How might warmer seas far off in the Coral Sea actually be making this cyclone worse? And then this cyclone moves into New Zealand. So it kind of, the changes that are occurring immediately around us, you have to think big picture, because those changes could actually be happening much further afield and then actually have these downstream impacts here locally. So forecasting is really changing, and we're having to consider the impacts of a warming planet, a warming climate on these events, and trying to communicate that then to people to try and understand, well, a warmer atmosphere holds more water vapor, and therefore events like the Auckland floods that we just saw are becoming more frequent. And you're seeing heavier rainfall falling, a 1 in 100 year event suddenly becomes, a 1 in 50 year event. And, as a forecaster, we are seeing these changes in real time. Fortunately, the physical aspects of the science, are strong, right? So, but we're having to, we're rewriting the climate record books here, and we're seeing more and more high temperature extremes, less low temperature extremes, and it's all happening so fast. And I think the quickness, the speed of it, is really what's striking to me.
And lastly, Ben, is this it? Is this what our summers are going to be like from now on? Or could we just as easily have a drought next year?
Yeah, this is something that we've been asked a lot. Is the summer of 22-23, is this the summer of the future? And the answer to that question is, well, yes and no. So we are expecting, as we go through time, more and more climatic extremes. And no better example than the case of Auckland. In 2019-20, we saw a record drought, extremely low rainfall. The dams here probably in the upper 30s in terms of their capacity. And there was real, grave concerns that, we're going to, run short of water.
Auckland's dams are running scarily low. Here at the Lower Huia, it's only at 37%.
I was told a few years ago when the top of the tunnel was exposed by someone in our team who's been in the water supply for 50 years. He told me that if we ever saw the full tunnel, it'd mean Auckland was staring down the barrel of a significant water shortage. Now we stand here and we can see not only the tunnel, but it's about a metre out of the water.
A couple years later, well, we're dealing with our wettest, what'll end up being our wettest summer on record, our wettest month on record. And those extremes are going to continue to occur more and more frequently as we go into the future because we live on a warming planet. Now, it won't be like that every single summer, but we do have things that we can look at, such as El Nino, La Nina, that give us clues as to what the weather may do for a given summer. So we had La Nina coming into the summer. We know that our odds are increased for wetter conditions in the north and east, although every La Nina event is a little bit different. We know the average outcome of La Nina, but no La Nina event is average. That's what we like to say. If we flip the script to, let's say, El Nino next summer, we could be looking at almost the exact opposite, where it's the lower and western South Island that is getting, hit with rain front by rain front, and the northern part of the North Island is not as exposed. So each summer is going to be a little bit different, but those extremes, like we have seen in recent years, just think Auckland floods, Westport floods, Canterbury floods, Tairawhiti, Gisborne floods. We had it last March, New Zealand's wettest hour on record in Mungatapere, which is near Whangarei in Northland. Those types of things have been affecting us more and more and more, and that is really what our future holds here.
Well, that's it for today. I'm Sharon Brett-Kelly. The Detail is supported by the Public Interest Journalism Fund. Today's episode was engineered by Jeremy Ansell. Our producers are Sarah Robson and Bonnie Harrison. And thanks to Ben Knoll. Ka kite anō.